talking. I know I'm coming in 3 to 5 minutes late, but I know I wanted to talk some more about Octopus's work, even if they're not able to join us. Plus, there was some cool stuff from TJ recently. I'm not sure if we hit that in the other working session. Do we have any other agenda items?
The only other one was an update from the Gitcoin side. I know there's been some conversations already about the live data we're seeing in round 9 with Sybil and collusion attacks by bots and other things. So maybe that could have a quick recap in this call, unless everyone is already familiar. I'm not sure who's been in any of the other calls where it may have been discussed already.
I think it's definitely worth discussing, though I'd probably defer to Iwaki to introduce the topic because I want to be sensitive to just like Gitcoin's own concerns on the topic.
Sure. Should I go into that now, or is that further down on the agenda?
I mean, if those three things are the agenda, I think it's as good a place as any to start. And I would actually say maybe that, then some of TJ's work, and then broader discussion on the the convex optimization work coming out of Octopus. And I think it's okay if that one comes last, simply because he is not able to join us. So we'll be taking notes and looping back with him anyway.
Yeah, that sounds great. So why don't we start off with what we're seeing live in the round? If you want to take that away, Iwaki.
Yeah, sure. So basically, we're seeing more scale than ever in the round is the TLDR. I think we're up to something like 70,000 contributions. I'll have to check the tweet, but on the order of 2 or 3x bigger than the last round in terms of contribution amounts. And then total contribution scale has gone from like 500K in round 8 to we're at like almost 700K now. So the bull market be bullin'. Based off of what I've seen, I have no doubt that we're being Sybil attacked right now. I think that one of the one of the sort of problems with our Sybil detection mechanism is that it's not very good at distinguishing between just a new user and a Sybil attack, and that's something that we're working on building tripwires into the system in order to do. And the thing is that basically Gitcoin's either advanced enough or it's a bull market enough that there's just a lot more money going around, and so the ability of my anecdotal data being able to make sense of this situation is limited because there's just so much data. It's like finding a needle in a haystack. But I'd say that we're definitely seeing an issue with people writing bots in order to move around contributions on ZK Sync and to send them from different ZK Sync addresses so that they can have their data returned in an API and be included in future airdrops associated with people who want to airdrop to Gitcoin Grants contributors. And so, that's one attack vector that I'm thinking about, just making it so that only one address per user shows up in the API in order to close that down. But yeah, just a lot more scale, I guess, is the high level message for Gitcoin Grants round 9.
So I would like to sort of unpack some of that. Thanks for the introduction of it. So on one hand, I think we're seeing multiple different sort of motivations for the attacks, and I think it would be interesting to unpack the difference between the Sybil and or collusion attacks we would associate to trying to maximize returns from airdrops versus attacks meant to directly affect the um, payouts from the match funds. And one of the reasons I want to highlight this is because this comes back to this idea that the incentives in a platform are not closed games. Excuse me, they're open games. In other words, there is a new objective function that didn't exist before. Now that people are using the Gitcoin dataset as a source for airdrops, the incentives to play the game Gitcoin, donation have changed from just get donations directly to plus get match funds to plus get airdrops potentially. And so the decomposition of that is one interesting topic I think we should spend a little bit of time on and understand how they are related and unrelated, and the way that maybe the responsibilities that we might see ourselves as the Gitcoin community having relative to that, and as well the Gitcoin organization. And secondly, I think it merits discussion about this topic merits the discussion about the process of catching, identifying, and responding to things. So, Owaki, you and I had a conversation about the four challenges associated with this, which I also think are worthy of enumerating. So, I'm kind of pause for a second for the group, but do you kind of see these as sort of sub-agenda topics related to this, round 9 activity?
Right. And I'll say that like we haven't interviewed the attackers, so we don't really know what their motivations are, but we can kind of surmise from their actions that people either want to like, what are the selfish things you can do on the platform? Well, you can push up a QF match amount, or you can put yourselves into further airdrops. And just based off of what we saw on chain, where a user was like contributing from a different ZK sync address every single time, we just surmised that they were optimizing for getting their address included in the API.
Right. And honestly, this is going to be a lead in to some of the discussion I'd like to have about TJ's work. So I'm going to peg it for a moment. But in terms of data sets, I mean, keep in mind that the airdrop thing is about how downstream policymakers use Gitcoin data sets. So at that point, Gitcoin isn't providing match funding, it's providing data sets about people who support, or I should say, about addresses which support public goods. And this mismatch between unique address and unique user is part of what creates the incentive misalignment, where people say, spam their activity through many addresses, so those addresses getting, included on these lists, so that any airdrops that are not proportional to donation size, they're just, is included in list type airdrops, are going to then kind of manifestly overrepresent these spam bots. And on the side of the airdroppers, this really comes down to how they do their algorithmic policy setting. Does it suffice to just have an address in a list? How much did they donate? What token did they donate in? What is it recognizable as part of a bundle? And so insofar as we have sort of provenance over these data sets, or a better understanding of how this data is generated, to what extent is there a necessity to inform or educate the downstream users of these data sets about how to use them responsibly, because ultimately that's what dictates the incentives of these sort of spammers who are looking for airdrops. And so I kind of want to again continue this, like, on one hand, the Gitcoin team is doing reviews and they're doing these sort of flagging algorithms, plus potentially talking to or evaluating individual cases, because that allows them to make decisions about the matching inclusion or exclusion. But it doesn't necessarily give them any rights with respect to Gitcoin platform, any rights with respect to the downstream use of that data. Someone who's using those data sets might still give an airdrop, irrespective of whether Gitcoin had actually, sanctioned or chosen not to count a particular donation in the matching funds.
May I have a question on this airdrop concept? We have basically two types, right? I remember that in last round, DAO did an airdrop on all contributors, so this was within the Gitcoin Grants campaign. But then my understanding of what you were just mentioning, Sargim, is of course anybody can use this data set of contributors to Gitcoin Grants, right? And here's any way to sanction? Does it make sense to sanction the data set, or try to shape the data set itself for anyone out there?
Well, there's two separate stages, right, Angela? There's the stage where what's the data set that, say Gitcoin exports through an API, versus what's the data set that's collected straight from the chain, versus what's the data set that's post-processed and used by the airdropper. So it's actually three different views. And we can think of it as the raw on-chain transaction data is the most basic, and that, in a sense, Gitcoin is exporting a post-process version of it through an API, something that they consider useful for their platform participants. But then regardless of whether you use a data that you've collected directly or from a source that's sort of more from the chain versus from Gitcoin, you would generally expect some sort of post-processing or yes, pre-processing for the airdrop that determines like, okay, let me filter this. Donations bigger than, or find ways to take that data set and process it further so that you get the airdrops you actually want. If you like basically data processes are always garbage in, garbage out. So, when you're doing that, I think people sort of bypassed the need to do a lot of the data cleaning by using the data that's available through Gitcoin because some of that processing had already been done. But I think it's dangerous to think that it's consumer ready because data sets are always context dependent. And I think there's just like an education component here that says this is what this data contains, this is what has been cleaned, this is maybe what hasn't been done to it. And if you want to be a little bit more rigorous about your airdrop, it might actually make sense to use something again, more like some of the data that TJ has prepared, and to apply your own queries based on the data found in the articulated logs. So I want to take this conversation for another few minutes, but if TJ's up for it, I would actually recommend him sharing some of his work. I don't know if you're cool with that.
Sure, I'm cool with sharing my work anytime I can. Should I go ahead?
Let's go.
I think so, yeah.
So I know if you know me at all, I've been working on this TrueBlocks for 5 years, and it's true. The basic goal is to figure out how we can get useful data from the chain, and that's been a real problem for people, I think. You can go to a third-party API, and there's a ton of those available. But for me, that kind of misses the point because I want to understand how to get the data directly from the chain for kind of any person. So I've been working on this thing for the last week or so. And I'm saying basically it's a permissionless gift to the community. And this is really the most important thing to me, is that we stop relying on providers of data and understand that this blockchain data is available to anyone who can get it. And what happens when that's true and we can actually get useful data. So I did use an API to get the names of all of these grants, but that's kind of the only data that I got from an API. So what this does is periodically, about probably once a day, it will scrape the chain and pick up any new data. And then it's simply creating downloadable files to show the data that appears in those smart contracts. So I'll just take a second here. So the data is a little complicated looking, but the thing that's of interest is this last piece here, which is, we call it an articulated data, or an articulated log data. And what this is every log for that address. And we export both JSON and CSV files. So this is the data Michael mentioned a minute ago. So what we do is we take this ugly, log data that everyone's familiar with, and we just call it articulated. And then you can download this data directly and do things like this, where you start looking at sorts of the data and filtering of the data and stuff like that. So the purpose is that anybody can get this data without kind of asking permission of anyone else. And I'm trying to build something that's really cheap to run, unlike, say, Etherscan, which increases in costs the more users they get. I really want to try to build something that decreases in cost. And that's why I'm so interested in IPFS for delivering this data, because I think that's a real opportunity there as well. So I did a pretty poor job explaining this, but it's basically just a data dump and then a little bit of analytics. So we look at the match contract, and we found that about half of all the grants did not claim their match. So I was going to put a link here for people that haven't claimed their match to go and claim their match and stuff like that. So I have a lot of work to do, but that's the general idea is just free and open data to anyone who wants it for any purpose.
I started playing around a little bit with the data set when you sent it to me, and although I'm trying to find, I have way too many tabs open, so I just had a Jupyter notebook running, and I pulled the data about the cadCAD grant because it's the one I'm the most familiar with, and one of the things that I started trying to do, although didn't entirely accomplish, was take the JSON and unpack the articulated log into something a little more like a flat table. And I had gotten to the point where I had something a lot more like an RDD. So it was still very row oriented as opposed to sort of columnar. But I was getting there with the ETL, and what I sort of imagined doing with it was kind of examining the event history in a sort of more data scientific way. And I think to your credit, the data set would be the kind of data set that I would use if I were going to do an airdrop. And again, I'm not, because we don't have any tokens for cadCAD, but if, for example, we were going to give a proof of attendance protocol token to everyone, or offer one at least to everyone who had donated, I would probably want to do something a little bit more like, okay, more than a certain amount, or maybe specifically drop a token for someone who donated during using Panvala because of the extra matching, or like find some way to actually put some business logic on top of it, or kind of putting myself in the role of the airdropper and kind of thinking about this problem that Owaki describes in the incentives. I see that if the airdroppers were going to start actually taking the time, or if there was a best practice for airdropping where you actually stopped and said, I'm not just going to use this data in raw form. I'm going to actually say something about what it is that I'm rewarding. It'd be quick. It would be pretty obvious that you'd quickly start knocking out the really obvious crap donations, because just by imposing relatively basic business rules about, oh, they donated in this time frame and they donated more than this amount, even if it's small, right? One die. Or it's like, maybe special to a token like, Rai's brand new. And I was thinking about doing some of my donations this round in Rai just as a sort of exercise of this new thing. Like imagine doing like a proof of attendance protocol for anyone who donated to any grant in, say, Rai, right? Like if I did that, like, or maybe above a threshold during the time frame. You get the idea. But the point here is that if you have these articulated logs, you can make things more conditional and less like, oh, well, it's in the data set, therefore, and thus do some cleanup around just making it less appealing to do these kind of mass spams, because you really don't expect them to make their way into the rewards as soon as you start introducing even the most basic filters on the data set before airdropping.
Yeah. So I'd say a couple of things. First of all, you can get that kind of data from other places, maybe more quickly and maybe more thoroughly. For example, Dune Analytics. The one thing that I'm focusing on is trying to build this so that a regular person on a regular desktop can actually get the same quality of data without accumulating the huge database like Dune Analytics. And then the other thing I want to say, and one of the things that happened because I kind of went that path where I did really small data, is I'm able to go really deep into the data. So I can get like all the way down to the very bottom of these DeFi transactions that might have 300 or 400 traces inside of them. And if you wanted to do really amazing analytics for things like collusion, we might find really interesting data down in the bottom of those traces. Because if I was being a very creative colluder, I might write a smart contract that purposefully obscures my data at the top level and kind of colludes way down in the depths of the smart contracts, 6 levels deep. And we can get that data, and I don't think you can get that data elsewhere. So that's another thing that's interesting. I did want to say one more thing about the data that I produce. I'm kind of not a data scientist, so I don't really know what the best format of this data is. So I'm like totally open to any suggestions about how I can improve it. Instead of like dumping data that needs to be manipulated by the user, I can easily fix the data or make it better. So if you have any suggestions, I'm totally open.
So I have a comment on both of those things. So for the wide versus deep, I think that's actually really important. I think one of the reasons I talked about the airdropping use case is that what I would expect is that someone who's doing an airdrop to have, whether it's based on Gitcoin or based on other activities, them to have more domain expertise around their specific product or application, and they would be uniquely qualified to use data sets that are like deeper, in the sense that they might actually want to be able to pull something that is too too deep to be wide in someone else's API, and to actually look at that data and make use of it to make decisions about what to, and specifically what kinds of activities to incentivize. So from a data science perspective, it's important to know the difference between the sort of the wide and the deep, and to bring data in that meets the needs of the decisions in question. And so I actually am motivated by your particular work in the context of airdrops beyond the scope of Gitcoin, precisely because policies about rewarding behavior often need to be contextualized and nuanced. Otherwise, and again, not overcomplicated necessarily, but just like they can be based on information that's a little finer grained. Then the point about the data structures, actually, I can stop for a second if you have a comment on the first thing.
No, I was going to say, I don't really look at it that way. I kind of look at it as just extracting the data, but I love that. I love thinking about that way.
Well, and that you extract the data, for the purpose. Again, this is the sort of data decision scientist in me is saying like, well, what the data is not there for its own sake. The user wants it for a reason, and their reason is affect their own. And so we want the data to be widely available to people so that they can go get and make the data set that they need, not the data set that someone else wants them to use or has made for them. That's part of the like sovereignty, the control over your own project, is not to necessarily be reliant on what someone else says was the activity, but what you think is relevant for your policy, for your rewards, or for your incentives.
Right.
On the data structure side, though, the best way to get good data structures or to iterate on them is to just use it to do things. Because, what I started to do and playing with it definitely required a lot of rewiring, but the instincts that I have are just to take the data as it's proffered to me and then, refactor it until it's, in a file format that's useful for me, and then to try to provide that back and say, well, I transformed it to look like this. And you can short circuit that sometimes, or in some cases you can move to patterns that are more natural with respect to existing tools. So one of the things I noticed as I was working through it is that a lot of the nestings don't unnest easily. Like I was writing a bunch of like custom ETL scripts to be like, okay, that's a dictionary, that's a list. Like I was scraping through the things that said name. You had a bunch of places that were like a name of a field, and then the value, which is actually like an overwritten dictionary in a sense. You have key value pairs, which I think could just directly be key value pairs. But
you'll help me clear that up, because that's where I need a little bit of feedback. Is kind of making it clean for data scientists. I want to do that.
But I only really encountered that when I started trying to transform it, right? Like it was very difficult for me to like, I looked at the JSON dump and I was like, okay, cool, it's a JSON dump. Once I started trying to turn it into the kind of data set I might use for an airdrop, because that was the exercise I was doing for the sake of informing this discussion. That's when I realized like, oh yeah, I have these like keys that are name and these other keys that are value, and I'm actually just unpacking them into a dictionary where I'm moving the thing that was in name to a key, and I'm moving the thing that was in value into a value.
Okay, I totally get you. I got you. Oh, that's great. Yeah, that kind of stuff helps me, so I appreciate that. Yeah.
Yeah. So anyway, does anybody else? I know we're kind of going off on our own little path here, but data is like a critical public good in the context of any sort of algorithmic decision making or algorithmic policy making setting. So I think it's very much worthy of attention.
So I would say that I think this would be very useful for a red team, blue team exercise to have people whose job it is to attack some testnet digital twin, people whose job it is to assess which grants were actually attacks and which were neutral, and that you could then do very deep analysis on the data, like you could do simulations and get data from the simulation.
Oh, I have an idea. I mean, this is your idea, but I think we should schedule a war game between rounds. I think that we could probably get this community.
Holy shit, so cool.
Yeah, I mean, like, there's no reason we couldn't do this, right? Because because we already have the simulation engine in the cadCAD model, we would literally be able to create a simulated Gitcoin round where, we played the game of Gitcoin, but we did a mafia-like thing where in advance we don't tell it. We like everybody signs up. We don't tell people who are the honest. We tell people, assign them the roles of honest attacker, and then basically play Gitcoin mafia.
And you will generate attack strategies that you wouldn't think of when you have no incentive to be clever.
Yeah.
And the best cheater gets the match.
Well, it depends on whether we catch people, right? If it's a mafia, the game is modeled after mafia, where we're trying to have the community, which, I mean, I guess assuming people have played this game mafia, right? Where at the beginning of the game, you draw cards and you get some rolls, and some people are attackers and some people are townsfolk, and the attackers like kill people off over the course of the game. In this case, we would just have to, kind of play through a simulated round where the attackers are like literally playing the game and trying to cheat, and the rest of us are playing the game and not cheating but trying to figure out or detect the cheaters. And then at the end we could have a sort of vote like in mafia to try to identify who the attackers were. And obviously the attackers are just playing, right? They're just pretending to be part of the townsfolk, which is of course very realistic in this case. And so then afterwards we do an analysis, figure out whether the attackers succeeded when getting away with it, how much money did they get away with in the process, and like the outcome is either the townsfolk identify them and sanction them and they get nothing, or the attackers succeed in remaining undetected, and thus their score is whatever they managed to get in match funds in the simulated game. But then we could sort of do a debrief and analysis. But I think this might be a really fun thing to do off round. I don't think that we should try to do it during the round, because we're doing the real life version of it right now by to actually catch attackers. But the difference with the war game is that we can debrief it better, because unlike in the real world version, we never really know who's colluding. In the war game, we've assigned the role and those people are really attacking. It's like having a supervised learning exercise. You know who the attackers were in the debrief. Whereas in real life, we're never gifted the perfect answer, like, oh, haha, those were the attackers. Did we catch them or not? And so the war game exercise exists largely for the legibility of the outcome that we'll never get in real life.
Sounds like a really cool idea for like an Outfront hackathon, and also it's like a DARPA Red Balloon Challenge kind of experience. So cool.
Yeah, so I think we should. I think we'll table it for now, but I would say that let's let the round run its course, because we need to turn our effort as a community towards our best efforts to help detect the real attacks in the real round. But then I think sometime during the period between the next two rounds, we should try to spin up and run a sort of some sort of incentivized war game, or we'll figure it out. But I think that discussion can be taken offline for now. As long as people think it would be fun, I think it's going to be scientifically informative.
Totally. I'm fully down on it.
Cool. So we used about half of our slot. Octopus is here. I definitely wanted to talk a bit about their work. So I don't know. Do you want to give us sort of the group an update, and then we can step into it, because I'm relatively enthusiastic.
Yeah. So my hope is that I don't the Discord channel. So my goal has been to come up with some rigorous, if small, results about how much one can gain if one is optimal colluding or if a team is optimally colluding. And I'm trying to. I unfortunately do not have the file readily.
I saw it very briefly. I feel like it came up.
Do you want me to try sharing screen, Octopus, since you're on mobile? I do have your collab. Is that what you're pulling up?
I would be willing to, if you would be willing to do that, I would appreciate it.
Sure, totally. Give me just 1 sec. It's loading here, and let me share. Okay, it should just be loading here. How's that? Is that coming through for you?
I can see the screen share.
Octopus, are you able to see that, or maybe are you muted, perhaps on your side?
Yeah, I can't hear him. I could a few minutes ago. It seems like we lost him in the process of the screen sharing exercise.
Yeah, we may have. So let me see here. What can I do? There we go. Right. So I guess until Octopus gets his audio back, he was just chatting about this at the last in our live coding session. So maybe I can give a brief. Probably very inaccurate. Yeah, I see he just dropped, so he might be trying to jump back in. So I think a lot of his work, and Danilo or Jaja or anyone who's more mathematically inclined, please feel free to step in if I make any egregious mistakes. But I think he was looking to do sort of the mathematical proof behind a few propositions within Gitcoin Grants. So we focused a little bit on this as a. Oh, great. Can you see my screen now, Octopus?
I can. Yeah, so our goal was to try to, so the strategy to determine the optimal subgraph for the optimality gap has been to use meta heuristics, and we've tried to formulate the problem in a way where we could actually view it function from a real vector space where the number of dimensions is equal to all possible contributions. And all that means is that if a contribution didn't happen, that edge be weighted to 0. And then we have to take this in such a way that, so basically I'm taking the pairwise coordination formula proposed by Buterin, and I'm assuming that all users have equal trust. The deviations due to non-equal trust may random. But basically I'm taking this function, I'm saying, what do I know about what the largest possible? And I have a conjecture, I have some supporting propositions that you can actually calculate the optimal value quite easily. If you have X users who have a budget of B, the conjecture is that optimal value is X times X minus 1 times B over 2 times quantity X. And I've actually written some propositions about different strategies that give this value. So one of them is if all users give the same amount to a single grant, then you're guaranteed to achieve this value, and I have a proof where I go through the algebra and show that is, and then I further, assuming my proof is correct, say that it doesn't really matter whether they're all giving to one grant equally or they're all giving to any number of grants equally. If you look at the optimum over all the grants who might be sharing in the profit, you still get the same amount regardless. So it doesn't help colluders to split and make new grants. It does help them to split and make new users. Making up fake grants is not a helpful collusion strategy. And so these kinds of strategies where everybody gives the same amount and just allocates them uniformly across some subset of the grants turn out that they are guaranteed to be critical points of the objective function. And the reason for that is that they're symmetric. So there's a theorem called the Perkis principle due to Whitehouse in 1986. It says when you have a function where the objective function and the constraints satisfy symmetry, then any fixed point under that symmetry is a critical. And so you're actually guaranteed that the strategies I've just described are either local maxes or local mins. You're not guaranteed that it's a local max, so I decided I needed to write a proof that it actually is a local max. That's what proposition 3 is, that at least some of these strategies you can prove rigorously are local max. And so my conjecture is that these local maxes are actually global maxes, and that would make the formula for the optimal subgraph something you could calculate, very easily. So unfortunately, I don't know how to do global max.
You might get it for free, actually. The thing that you need to do is prove that I guess not quite for free, but if we look at the problem that you're solving, I think we could prove that it is equivalent to a convex optimization problem. So as it stands, it's written in a sort of, because of the divisors and stuff, its current form, it's a little questionable, but I think that it just intuitively, I'm under the opinion that, I mean, like, to be honest, like the way that it's constructed, right, the whole quadratic matching is effectively a kind of like weirdly presented, but generally thought of as a convex framing of it, right? Because the roots come from the solutions to problems with powers, and so with a little bit of analytic finagling, my expectation would be that we could prove that the problem itself is convex. And if the problem itself is convex, then all local minimum are global minima, all local maximum are global maximum. It's a property of convex optimization problems.
So that would be nice. So this is what's known as a quadratic sum of ratios problem. And in general, it's NP hard, according to the latest literature. So my reformulation was to try to exploit this tree. A single quadratic ratio problem can be reformulated as a convex program, but I did.
Interesting.
Yeah, if there's a paper I'm missing, I want you to point. I spent a long time early Tuesday morning hoping that this would work.
But you were saying that a single, I don't have a paper offhand, but we can kind of tease at this a minute. So if a single, when I saw what you posed, I was thinking of something like a second order cone program, which was their SOC DPs are like convex equivalents. It doesn't seem like this is exactly that if there's already literature saying that it's NP, but there still might be, even a problem that is in general NP may have any number of specializations that could cause it to collapse into a convex problem. And what you were just describing, where a single version of this problem instead of many, I guess what did you say it was a roots? What was the name of the problem?
Well, so first of all, I make the substitution so that I'm working with the contributions. I make the square root of the contributions be the original variable, and then the constraint is sum of things.
Yeah, I think that's a good transformation. That's what I was saying about the original formalization of the QF. It feels a little awkward to me to have all the radicals running around. I actually think it makes more sense to think of the decision variables the way that you're describing them. So I tend to agree with that as a first move from an analytic perspective.
So the formulation of a single quadratic ratio as a convex problem is due to Scheibler and Xi, and I can send you a general sum of ratios problem, not necessarily quadratic, is NP. And so then the question is, what's in the line between them? If you're saying that going from a single type of this to a sum of a type of this, that there's a trick, I'm really hoping there is. So I want to talk about it more if you have ideas.
Yeah, that's kind of what I'm conjecturing, is that there may be through the potentially even by way of one of the symmetries arguments, a way to collapse it such that you get guarantees. I don't think it's necessarily free, but for me, this all basically comes back to, regardless of what argument path we take, is whether the problem can be shown to be equivalent to a convex problem. And so there are direct and indirect methods for doing that. So like the textbook that I sent you has machinery for just proving whether a problem is convex, but you can also show optimization problems are equivalent to convex problems, which is actually possible for things that aren't actually convex. So things like generalized geometric programs are like really ugly non-convex problems, but because they have transformations to convex problems, they still land in P. I think one of the things though that I would tease at with this problem in particular is just like a couple additional reframings based on, similar to what you did with the changing the decision variable to the square, to try to get it to either make it so that there's a direct proof that something is convex, or that it can be cast in a form that we know is a convex problem. And the one that came to mind for me was something called a second order cone program. There's a couple other sort of like weird problems that are like surprisingly common that end up being convex. And actually, again, if you were to like flip through that Boyd and Vandenberg textbook, you'd find sections on some of them. But I'm not sure that the second order cone problem would do the trick, but it tends to arise when you have these kinds of squares and ratios, and it requires quite a bit of manipulating the problem to get the equivalences, because they work with cones, which are matrices, essentially symmetric matrices. The interesting thing about this is that the contribution graphs are closely related to matrices, in particular gram matrices.
I understand that, but if I could my point quickly.
Yeah.
I've tried search through literature to see if there is a standard technique for converting this type. And I think alternative approach to be worth pursuing if the convex angle does not work out is to realize that the constraint is now an n-dimensional sphere.
Okay.
Which has the advantage that, unlike the feasible region of a convex hull of something, it has no corner point. So everything is interior, and you don't have to worry about the weird case of, well, what if I hit the corner polyhedron?
Yeah.
And so there's an excellent book that to you that's about optimization on manifolds, and I'm hoping we'll have optimization on a sphere. Optimization on a sphere is easier to exploit this. And my second comment is that I have Python code here where it is taking. There's an excellent Python library for optimization on manifolds. So even if we can't prove that this is a global max, can at least generate, well, in these 2,000 different cases, the global max agrees with.
Yeah. Also, I think the suggestion I'm making is more similar to what you're saying. Like, actually, part of the way that those programs that I was describing work is that they actually come down to, well, this is probably too deep of a mathy tangent here, but it relates to the shapes of the manifolds that you're working with. Cones are just weird spaces that have nice properties, but your observation about the sphere is similar to the way that the constraint sets are defined. And even if you have a constraint set that's like not convex, those types of problems almost always have their solutions on the surface of the sphere, meaning it never makes sense not to allocate all the resources you have. So you can recast it as an inequality instead of an equality because the solutions lie on the surface of the sphere, which is actually part of the process of finding the convex equivalent to the non-convex problem, is to identify things like the equivalent problem on the inequality is convex, even though the original problem was equality and thus non-convex.
So, I mean, yeah, so my comment is that I feel like I'm 95% of the way to a theorem, and I would hope that this bound, being able to compute this bound more easily, is helpful, even in the absence of proof. But in the hackathon today, we were seeing grants whose contribution exceeded this conjecture, which either means the conjectured bound is incorrect, or there's something the quadratic formula code, the way it allocates things, does not jibe with.
Does the trust score potentially explain it? Does the exclusion of the variation in the trust scores potentially explain the violation of the constraint?
It does explain it. The trust, I mean, it would explain it. The trust score destroys symmetry. But what one might hope for is if not a perfect, at least a quantitative or geometric intuition about how the score destroys the symmetry and how it would adjust this optimal value. It seems that since the trust score is bounded, you can take and just assume that everyone leeches off the most trusted user, which would mean that you could take this bound and multiply it by the maximum trust score and get the correct. But I appreciate your comments very much, and I look forward to learning how to do the things that you.
Yeah, I definitely want to. I mean, I apologize. I mean, really, for me, it's that like this is intensely interesting to me because I have not seen much in the way of good quality applied usage of literally my PhD work was on optimization theory in networks, and like a lot of the convex optimization work is stuff that I love, but also it's sort of kind of arcane. And so, running through proofs to figure out bounds on the variation in optimals relative to some real world problem is basically the I hate to say, sort of like academics is very self-fulfilling a lot of the times. Like you just do stuff because someone decided you should do it. And I spent years in I literally taught convex optimization at Penn, and I taught people how to use it to derive ML algorithms and to do lots of stuff, and no one cared. So there's something like deeply satisfying about seeing you on the problem with the convex optimization, or even just more general optimization toolkit. The challenge is that it tends to be time consuming and kind of deep work. So amidst a battery of other things that are more like firefighty, I haven't gotten to spend the kind of deep thinking on it that you have, even, right? That it merits. So that's kind of where I'm at, like intrigued and excited for your efforts, and a little bit jealous of the fact that you've had time to kind of fight through some of the analysis.
It involves waking up at 3 a.m.
So. Less jealous of the 3 a.m., but I have a 7-month-old daughter who regularly wakes me up at 3 a.m.
Exactly. That's why I have an 11-month-old son. So when he wakes me up, I just get on my phone and start writing notes.
Gotcha. So I guess we have about 5 minutes, and one thing I'd like to do, I know that this might have been a little bit off the deep end for a lot of people. Context is just that like the math heavy stuff tends to be very, honestly, it's kind of creative work. There are conjectures, explorations, look up references, try to figure out whether your intuition can be made formal through either existing proofs and theorems or basically first principle definitions, which is still basically for theorems, but that's kind of the nature of this work. And I personally think that this is the kind of work that on which a lot of the other stuff is founded. It's just that more often than not, this kind of work is 2 or 3 times removed by the time you're using an algorithm or an app or whatever. And so I think at minimum, it's worth highlighting it as just another kind of public good that the broader token engineering world relies upon. It's just that for the most part, we're relying on stuff that someone did 10, 20, 50, whatever years ago. And it still requires some people to be doing it, to like learn and discover theorems and proofs that underpin algorithms, which underpin systems. So I don't know if people have questions or comments or Octopus, I mean, I feel like a lot of the time when we get into this level, probably half or less of the group that's probably keeping pace, but I still want to be motivating it for people, especially if they're interested in learning.
Yeah, I'm always happy to try to explain it in a less formal way, symbolic ways. If anyone has questions, please feel free to ask me. And if anyone has, I really do covet your expertise on geometry and analysis, because to be honest, I'm a discrete mathematician and an algorithms person, and this kind of thing is stretching me pretty far. I'm not.
I mean,
I just know how to read the literature when I need to.
It's like when coders say that they don't know how to code, they just know how to Google. It's for mathematicians too.
And an analogy I use for a lot of this stuff is, we're talking now about the the inner workings of the combustion engine, when at the high level, most people just want the sports car. So some people are interested in opening up the hood and looking at it. Some people are interested in, pulling out the engine and deconstructing and reconstructing it. But a lot of the people are just interested in the performance of the car. So I think as long as we kind of, understand there is drill down depth into these topics, where it's important to have, those foundational mathematics. For example, in this case, we can still kind of abstract up to, the importance of this mathematics in the resilience of these tools.
Yeah, and I still think that this part of the work, this work on the algorithms and how to reshape them, should be and must be part of the token engineering process. And it probably won't be always that intense, but I think, I mean, we discussed this Octopus, making this accessible. Perhaps I would be really keen to, once we've made it to a point where we can say, okay, this seems to be a theorem, and here's the process from quadratic funding where we started, and now this reformulation and why we did this and how this takes place. And perhaps we can find some additional expressions or visualizations to make it more tangible. I think that's really important. I would be happy to not leave this to a very special, somehow weird portion of token engineers. This should be just in the center of everything. I think it's so important to be aware of these algorithms. Yeah. Just saying. Thanks.
Absolutely. And we have another piece planned on the optimality gap, going into a bit further detail about how it can be used as a collusion flagging mechanism, and definitely all of this rigorous kind of deeper mathematical work plays into that. So definitely much appreciated on the work and attention, Octopus and Z, Danilo, Jaja, and the mathematical and data science wizards among us.
So Octopus, I threw in the TE Gitcoin channel a link to just the Wikipedia article on second order cone programs, and I also just made a note about the whole sphere thing, because this intuition about these kinds of programs does require this observation. Like, we wouldn't get one of these problems by simply looking at optimization on the sphere. We would get to a convex program no matter which form we take, by first relaxing to say that we're actually going to include the set of all allocations that use as many resources as you have in your you had in the original problem, or less. And by filling in the sphere, we get around a lot of the headaches that might come from having a non-convex set to optimize over. And these cone programs are one of the approaches to that, but it may not actually be necessary. You might find that the problem becomes much easier quite quickly once you allow this equivalence argument. And the way that equivalence argument basically works is to say that the optimal decision variable and the optimal objective score for the problem with the whole sphere and the problem with the surface only are the same. And you get to that argument by basically just saying that for any point in the interior of the sphere, there's a point that's as good or better on the sphere, which I guess is strictly better on the sphere, because you don't want to land on a point not on the sphere. But there are kind of, I guess there's not really standard techniques. We're operating in a domain where, like, I would think of this as largely creative, because what you're doing is first building an intuition, then reframing the problem, then proving that your reframed problem has the same optimal solution as the previous problem. But when you do that, you get any property, you can attribute any properties to the original problem that the reframed problem has. It's through this equivalence method. Oh, he's gone again.
Yeah, he may be having some internet issues, just to guess.
Yeah, and I think we should try to wrap up on time here. I appreciate everybody joining. But anyone else? I mean, I have a feeling that we're working towards sort of more of I don't want to say like a split, because I like the cross sharing, but a lot of this sort of more advanced sort of mathematics part of token engineering is complementary to the computational part of token engineering. But one of the reasons why I think it's tough to get to is it requires sort of a higher level of prerequisites. Like the kinds of stuff we're talking about builds on linear algebra and calculus and discrete maths and real analysis. And, you know, it's kind of fun if you have the literacy already, but it can be very daunting if you haven't had those topics in your, like, you know, formally.
Yeah, definitely. Well, glad to see these initiatives are bringing in the right type of people. And then, yeah, I mean, you know, if you look at any other engineering pipeline, you know, there are so many areas and specializations within any engineering discipline. And as we've chatted about before, I think, you know, token engineering is still a point, and we're seeing this like elongation into a pipeline where, you know, you have math specialists, data science specialists, developer builders. You know, we've got all kinds of different specializations within token engineering. So I think I'm happy to see this is starting to come about, even if it comes with the sometimes grueling learning curves that these areas even exist in the first place. But yeah, really happy to see how this is progressing. And yeah, I don't know if there were any other final thoughts or closing comments. But yeah, happy to continue the conversation into the next week, and make sure we're all there for the Gitcoin team to support you know, this kind of live collusion and Sybil identification process. I think there's been a lot of really cool insights and resources coming out of these groups. So yeah, happy to see how it continues to play out.
Yeah, and let me just make a final comment. I think in around 2 weeks, the research group officially concludes, meaning we were planning to work until April the 2nd. And I think it makes sense to have, say, at least a preliminary presentation of the results there from all the participants in the group. Most of them, or let's say half of them, are not here tonight. And then, of course, I guess it's also good to discuss how to continue, since we just made a starting point and detected such, I think, a rich variety of topics to continue. So we started with vector, with attacks. We are currently observing our potential attacks. Then the war games, mafia wars game, and math, how to make algorithms more tangible. So there's really a richness, and I'd be glad to be able to continue this with the community in a similar fashion. So this is to Block.Science and Gitcoin. Let's discuss how to make the presentation and then what could be next steps.
Cool. Sounds great.
All right.
Awesome.
Thank you.
Thanks so much, everybody.